Alright, so this video is for nonlinear regression models, and our learning target is I can model and solve problems using nonlinear regression models. So, on Haiku, on the right hand, in the right hand column, I have some videos that'll show you how to do this on the calculator. There are videos if you're using a Desmos calculator, and there are videos for using a TI-84 calculator. So I need you to watch those videos based on which calculator you're using. So after you know how to do them, you should watch this video. Okay. So regression takes a set of data and creates an equation that best fits the data. The shape of the data will determine which regression model is used. Sketch the nonlinear regression models below. So exponential is one you should be pretty familiar with. It looks like this. So anytime you plot some data and it looks kind of like that, you're going to use an exponential regression model. A power model is very similar. So something like that. Logistic is new to you as far as I know this year. So it'll look something like this. And then logarithmic looks more like this one. Okay. And then usually in the problems they'll tell you which kind of regression to use, but this is just so you know. Okay. So remember, you're doing these and you're watching the videos based on which calculator you're using. I'm not going through the actual calculator steps. I'm just going to show you what model you should get, and then we'll solve some stuff with it. So the population of a city in thousands from 1995 through 2000 is shown to the left. Well, it's actually shown below because I didn't have enough room. Use exponential regression. So this one tells you to write an equation to model the data. So first thing you need to do, make sure you know how to do this. I'm going to use 0, 1, 2, 3, 4, and 5 for the years just because I think it makes it easier, but you don't have to do that. Alright, so it doesn't matter which calculator you use, you should all get this model for exponential. Alright, so the second part says, find the year in which the population will reach 80,000 people, my bad. So remember, this is measured in thousands, so I'm going to do 80, I'm going to replace y with 80. And now I'm just going to solve like we have been this entire year. I want to get this part isolated, so I'm going to divide both sides by 54.66. Alright, so I get 1.46 equals 1.01x. So then I'm going to take the log of each side. And then remember, anytime I have an exponent, I can write it in front of the log. So this is going to be log 1.46 equals x log 1.01. I want to get x by itself, so I'm going to divide both sides by log 1.01. So x equals 38.03. So remember, this video is not showing you the calculator steps, it's just how you actually use the model they give you, and then we're going to solve something with it. Okay, for the next one, the body weight in pounds and the pulse rate in beats per minute of a group of animals is shown, not to the left, it's right below. Use a power regression, so it definitely tells you which one to use, to write an equation to model the data, then estimate the pulse rate of a 225-pound animal. So, after watching the video and figuring out how to use a power regression, and if I didn't put that on Haiku, just Google it on YouTube, whatever calculator you're using, how to use it with power regression, and there'll be a video for it. But you should get this. Okay. And then we want to use it to estimate what a 225-pound animal would be. So my x is going to be replaced with 225. the nice thing about this one is I don't have to solve anything. I just have to type it in my calculator. So I get 61.54. Okay. Alright. So here's two more examples. This one tells you to use a logistic regression, which is nice. And then the next one's going to tell you to use a logarithmic regression. So make sure that you do notice that there's a difference in those words, that's a difference in those formulas. Okay, so the table shows the temperature each minute after an oven is set. Use a logistic regression to rewrite an equation to model the data, then estimate the time it will take the oven to reach a temperature of 425. So, when you use the model, it's ugly, but it should give you this. Okay, and then we want to use it to estimate the time it will take the oven to reach a temperature of 425. So y is the temperature, so I'm going to replace y with 425. And now I'm just going to solve it like we have in previous lessons. Yeah, my handwriting's getting worse and worse. Alright, so the first thing I'm going to do is I'm going to multiply that quantity on the bottom to the other side. And then I'm going to divide both sides by 425. So I get 1 plus 7.01 e to the negative 0.3x equals, my calculator says 1.13. Alright, so then I'm going to subtract 1 from both sides. And then I'm going to divide both sides by 7.01. So I got e to the negative 0.3x equals, I got 0.02. JK, no I did not. I still can't read. Okay, I got 0.16. Okay. Okay, I've totally screwed this up. What is going on? Let me do this again. Sorry, guys. Alright, so for here I got 1.13. And then I subtracted 1. And I got 0.13. And then I divided by 7.01. Oh, okay. Alright, sorry. Just confusing myself. Alright, pay no attention to me. Okay, so now we're going to natural log both sides. Alright, so I get negative 0.3x equals the natural log of 0.02. And then the last thing I'm going to do is divide by 0.3. Alright, so I get x equals 13.4. If you wanted to say 14 minutes, that'd be the same thing. So whichever one makes more sense in your head. Okay, so then for the next one, we're going to do a logarithmic regression. So the table shows the enrollment at a new community college in each of its first 8 years. Use a logarithmic regression to write an equation to model the data, then estimate the enrollment of the college in its 15th year. So no matter which calculator you're using, this is what you should get, unless I totally screwed it up, which has been known to happen. Ew, I'm running out of room. Okay. And then I'm going to estimate it in its 15th year. X represents year. So I'm just typing this into my calculator. Natural log 15. And I get 4,329.62. We kind of don't want a mangled body student, so let's just say 4,329 students. Okay. Alright, so let's look at choosing the best model. So sometimes they're not going to tell you what model is best. So to determine the model of best fit, we're going to use something called the correlation coefficient, which is represented by the letter R. The closer R is to -1 or 1, the better the fit. So when you do this and it gives you like a model, like a little window like this, when you look at R down here, the closer it is to 1 or -1, then the better the fit. So this would be like a pretty good fit model. Alright, usually you do correlation coefficient in Math 1, and then we really don't talk about it in Math 2 and Math 3 that much, so it's probably been a while for you. Okay, so the table below shows why the average price of a gallon of gas at a gas station in years since 2001 X. Determine whether a logarithmic or exponential function would be best for the model. So then we're going to find something. Okay, so the first thing I want you to do is I want you to come up with a model for logarithm and exponential functions. So do that using whatever calculator you want. And I want you to look at the R, the correlation coefficient, and see which one is closer. So pause the video and figure out which one has a closer correlation coefficient, and then use that one. So do that in 1, 2, 3. Okay, so you should have found that exponential was the best fit model. So we're going to use the exponential one. Alright, and now we're going to find the year in which the price of gas will reach 3.25. So remember, Y is your price of gas. I'm going to replace Y with 3.25. What the heck am I writing? Alright, I'm going to divide both sides by 1.13. So I get 2.88. I'm going to take the log of both sides. And remember, my power property says anytime I have a power, I can write it in front of the word log. So I have log 2.88 equals x times log 1.2. So then the last thing I'm going to do is divide both sides by log 1.2. So for this one, I get the x is 5.6. And we are talking about years, so I would say year 2007. Okay, we're going to do pretty much the same thing with the second one. So the table below shows X, the wingspan in feet, compared to Y, the weight in pounds of 5 birds. Determine whether an exponential or a power function would be best. So what I want you to do is using your calculator, I want you to find an exponential model and a power function model and see which one has the closest correlation coefficient. So try that, pause the video and actually do it in 1, 2, 3. Okay, so you should have found that the power model was the best. So we're going to use the power model. Alright, and then it says, then estimate the weight of a bird with a wingspan of 5 feet. So X represents the wingspan, so I'm going to replace X with 5, and this is a nice problem because all you have to do is type it in your calculator. Alright, so that's pretty easy. It's not bad. Just knowing the calculator steps, understanding the correlation coefficient, and then just knowing how to solve an equation. Alright, let me know if you have any questions. I'll try and answer them.